Hello everyone, welcome to Data Science School. Today we will discuss about one of the most important part of the data analysis, that is handling missing values. So we have different data sets in different competitions or different project. There we have some missing values. So we need to fill those missing values or we need to delete those missing values based on our decision. We need to analyze the data and project to decide what we will do with the missing values. So first of all, I will discuss different strategies of handling missing values, and also I will discuss one of the advanced level strategy of handling missing values. So first of all, I will import NumPy and Pandas library. Then I will read the Titanic dataset as I am using in my different videos, same dataset, so that you can correlate my videos. So here you can see the data frame from the Titanic dataset. Here you can see lots of missing values in Kevin column, and also we have missing values in age column also. So first of all, I would like to see the number of rows and columns of the data frame. So we have 891 rows and 12 columns. So do we have any missing values in our data set? So data is not.sum will show us the total number of missing values in our data set. So here you can see 177 missing values in age column and 687, almost 80% of the data missing in Kevin column, and we have 2 data missing in Amberg. So we have like nothing in Kevin column, so we cannot use or impute missing values for this column. So first, the strategy is deletion, where we will delete all rows that contain non-values or missing values. For that, we need to write the command data.dropNow. So here I am assigning this command to X, so that X is a new data frame, so I don't need to change the data every time. If you want to see the reflection in the data set, you need to put in place true. That will actually do the main thing in the main data sets. So here I am going to drop all the rows that has missing values. So you can see the new shape of the X, that means our data set is 183 rows, where we had 891 in the initial stage. So data.dropNow drop all the missing values, all the rows that has missing values. The second strategy is removal of variable. That means we will only remove the column that has missing values. So here you can see 80% of the data are missing in the Kevin column. So that is why I don't want to impute missing values in this column. Rather, I want to drop the whole column of Kevin. For that, we will mention the Kevin the column name data.drop Kevin and access 1. If you want to see the reflection in the data set, you need to put in place equal to true. So this is the main changes in the main code. I will show in the last part of the video that how I'm changing the whole data set with in place is equal to true column. So here is the new X.shape. That means you can see we had 12 column. Now we have only 11 columns, so we don't have Kevin anymore. The third strategy is mean, median and mode. So first of all, I would like to see the mean and median of the age column, as we have 177 missing data in age column. So the mean age of the data set is 29.69 and median of the age is 28. So if I want to impute the missing values with mean, then I need to put this command data.age.filna, and here is the command that will actually fill the missing values with mean. Exactly same thing, like if you want to see the reflection to the main data frame, you need to put in place is equals to true. So here you can see in the X is now we have missing values 0. That means all the missing data in the H column has been replaced by the mean of the H column. If you want to do that with median, you just need to change the end part of this column command, that median instead of mean, that will replace all missing values in the H column with median of the H column. So here you can see we have 0 missing values. If you want to check whether it is actually happening or not, we can check that. Here is the first 6 rows of the H column, and we have none values in 5th column. That means missing values in 5th column. In the first strategy, we impute the missing values with mean. So let's check with x.head. Here you can see the missing values is imputed by 29.69. What was our mean of the H column? What about the Y? You can see that it has been imputed with 28. What was our median in our H column? We can impute missing values with mood. That means most frequent. So these are the different strategy we are using, because embedded is a categorical variable and it has S. You can see in the main data frame it has S, C and Q, 3 variables. So you cannot impute, you cannot calculate the mean or median of categorical variable. So you need to impute embedded with most frequent. So that is what I'm doing with embedded.mood. So here the mode of the embedded is S. That means the most frequent is S in the embedded column. You can check with value counts also, like 644 data in embedded column is S. We have 2 missing values in embedded column, so we can impute those missing values with this column, where we will fill the missing values with most frequent, that is S. So you can check here, we don't have any missing values in embedded or jet. So now you can check the value counts of the jet. That will show you we have 2 more data in S, where we have 644. Now we have 646 data in jet. So here now I will show you guys how we can reflect this strategy into the main data sets. As I mentioned that you need to include only in place equals true. So here data embedded.fill now I'm using most frequent as in place true. That means this imputed into the main data frame of data in train set, and data drop Kevin axis 1 in place true will drop the column Kevin from the data set. After running the command, you can check the missing values. So here you can see there is no Kevin column and we don't have any missing values in embedded. Now we have only 177 missing values in our dataset. As I didn't impute or mention in place true for age, it didn't reflect in my dataset. I retained these missing values for age because I want to show more advanced way, more advanced strategy to handle missing values. For example, if you replace 29 with all the missing values, that means you are replacing age of a children with 29. It can be happening. So in that cases, you can do imputation for a specific category. Here I choose the category as sex. So you can calculate the age for different sex. So for female we have average 27, for male we have 37. In the advanced video I will show you guys how to handle these missing values for children, boys, girls, man, women, when I will define the whole data set into different titles like Mr., Mrs. and other. So now I have age mean for different sex, for female and male. Now I will impute those different mean to the data set. So this command will impute that. Here I mention data age. I'm assigning this value to data age, so this will reflect the main data set. So you can check this function, pretty simple, where I define how to impute based on the mean. And if I run the function and then check the whole data set for the final time for the missing values, you can see here is no more missing values in my data set. So thank you so much for watching these videos. If you have any question, you can ask in the comment section. Thank you and stay tuned for the next video.